Okay, so the next section is we're going to call library of functions. We've looked at some of them already. We have. Let's just add a page here and talk about some of the different kinds of functions that we have. We're going to look at. Or like I said, we've already seen them. But you've got lines, straight lines, I guess, or a linear function. It usually has a form y equals mx plus b. That's the slope-intercept form of the line. And then you've got, we could say a parabola. We could say a second-order polynomial. So there it might be y is equal to ax squared plus bx plus c. So it's got an exponent of 2 instead of 1. Then you've got, we might call it a cubic, or we call it a third-order polynomial. And what you have is y equals ax cubed plus bx squared plus cx plus d. And in this case, m cannot equal 0. Here, a cannot equal 0. And the same here, because if a is 0, then it reverts back. Here it reverts back just to a horizontal line. Here, this would revert back to a linear function or straight line. And this one would revert back to a second-order polynomial. Okay. Then you've got things like the square root of x, and so that'd be the square root function. And that's the kind of the simplest version. I guess, coming back here, the simplest version of this would be just y equals x squared. Here would be y equals x cubed. So you wouldn't have any of the lower order terms. You just have the highest order term with a coefficient of 1. Here, the simplest would be y equals x. So that's the simplest form of a square root function. Then you have, then you could have like a reciprocal function. So that's kind of the simplest rational function. Ratio of polynomials. So the simplest numerator would be 1, and the simplest denominator would just be x. And then you could have something like the absolute value of x. That's the absolute value. And what we're going to do is we're going to look at all of these kinds of functions and think about what are the following characteristics. And what we do is we call the simplest version the parent function. So this is the parent function of the square root. This is the parent function of the reciprocal. And then we want to look at how adding, subtracting values to the argument being, say, the term inside the parentheses here. So, the next, we could have something like the square root of x minus 2 plus 3, where we have the 3 outside the square root and the negative 2 in the square root. Or you might have something like this, x plus minus 4. So this would be the parent function. This would be something a little more complicated than the parent function. Okay, so back here we've got the domain, the range, whether it's an even or odd function, x and y intercepts, whether the function is increasing or decreasing in certain intervals, and if there's any kind of symmetry. The odd and even kind of gives you some idea of the symmetry. So the first thing we're going to do is look at a linear function. So these are both linear functions, have the same slope. You can see 1. And what these numbers here do is they just shifted vertically. So if I were to draw the parent function, it would look something like that, sort of like that. Actually go right there based on this scale. So this would be y equals x, and actually it doesn't quite look like that either. It has to go through the origin. So let me see what we have here. So up to 5. So that's 5. So actually, maybe it would have worked the other way. Anyway, there's -5. Okay, so that looks good. And what you can see is that the blue line is the same as the black line, except that it's moved vertically 3 units, and this one is the same as the parent function, except it's displaced vertically. So let's think about what's going on here. Domain, those are the possible x values. So that's going to be from -infinity to positive infinity. Notice I don't put an equal sign here, or we could do it like this, -infinity to positive infinity. The range is also from -infinity to positive infinity. Those are the possible y values. Can't equal infinity. Is it odd or even? It's odd, because if I go for a given line, if I go -x and I look at the y value, and I go positive x, look at the y value, you see that they're opposite signs. The x-intercept, it depends upon, what you would do is you would set y equal to 0 and find the x values. So in this case, the x-intercept, if you set y equal to 0, you get x equals -3, which is that value. Here, when x equals 0, y equals 0, so that's the x-intercept. Here you'd set equal to 0, you'd find out the answer is x + 3. To find the y-intercept, you'd set x equal to 0. So for this curve, the y-intercept would be 0 + 3, or 3. This is your y-intercept. Here, it's there. And if you set x equal to 0 here, you get the y-intercept, so you get y equals -3. So those are the y-intercepts. And in terms of increase, it's always increasing or decreasing, one or the other. So in this case, all of these are increasing, and that's because of the slope. So what we could say is that, let's write it down here, if m is greater than 0, it's an increasing function for the entire domain, and if m is less than 0, which is a slope, then it's decreasing. Okay, so that's the linear function. Okay, now we have a parabola, and it looks like I might be using this part. So this is our parent function, y equals x squared. So what would non-parent functions look like? You might have x + 2 squared minus 3. So I've got a term inside the parentheses. I've got one outside. And each one of those is going to cause a translation of this function in the x and y direction. But we're not talking about that yet. We're just looking at the domain of the parent function. So the domain is, again, all real numbers. Those are all the possible x values. Whereas the range are the resulting y values given the domain. So here you would say that y is greater than or equal to 0. It's an even function, and that's because if I go this direction, certain distance, measure the y value, and I go the opposite direction relative to the center point of this thing, you get the same y value. So that's an even value. The x and y intercepts are just 0, 0. That's this point right there. And what we could, in terms of increasing or decreasing, we could say when x is less than 0, it's decreasing, because the y value is getting lower, lower, lower until I get to x equals 0. So for x greater than 0, it's an increasing function. And is it symmetry? Yeah, it's symmetric around the vertical line x equals 0, which is the y-axis. So things on this side are symmetric to that side. Okay, so that's a quadratic. Cubic function looks like that. Y equals x cubed. Again, the domain is all real numbers. Polynomials typically have all real numbers as the domain. There are no values of x that don't work. The range is also from negative infinity to positive infinity, because this curve goes all the way down to negative infinity and then up to positive infinity. This is an odd function, and again that's because if I go a certain distance in the x direction, find the corresponding y value here, and I go the same direction from the origin along the x-axis, but negative-wise, the y value is on the other side. So this distance from here to here is the same distance from there to there, so it's odd. And again, the x and y intercepts are that. And to be fair, we should probably show both coordinates. And in this case, intervals of increasing or decreasing. So it's increasing. Actually, it's increasing everywhere except one point. So it's increasing from negative infinity to 0, and it's increasing from 0 to positive infinity. Now at x equals 0, it's neither. Okay, got the square root function, so the domain is always going to be, well, for the parent function, it's x is greater than 0 and less than infinity. I could show that again as it kind of equals 0, so I'll put an equal sign there. So we'd use a square bracket there, 0, comma, infinity. That would be one way of doing it, and we have to use a rounded bracket on the upper limit because it never equals infinity. You might just say x is greater than 0, and that kind of implies that it goes on to infinity. The range you can see is greater than 0, so y is greater than or equal to 0, less than infinity. It goes out to infinity slow, but it does go out there. It's neither an odd or an even function. The x-intercepts and y-intercepts are 0 again, right here. And we can show that by 0, comma 0. X equals 0, y equals 0. It's always increasing. So it starts out increasing, and no, none. So there's no symmetry with the square root function. So that's the basic idea there. The reciprocal function. So the domain of the reciprocal function is all real numbers except where we have the vertical asymptote, which is x equals 0. So the way you do that is you go negative infinity x to 0 and 0 x to infinity. X cannot equal 0 because if you let x equal 0, then the function is undefined. The range would be negative infinity to positive infinity. Again, it wouldn't include 0 because it never actually equals 0. It just approaches 0. So we'd say y is from negative infinity to 0 and from 0 to positive infinity. Is it odd or even? It's not really odd or even. Yeah, I guess you might say it's odd. Because if I go this far to the right, I get this value. If I go to the left, I get this value. So there's the same magnitude, the same distance from the origin to here, but they're plus minus. There are no x-intercepts and there are no y-intercepts. And from it increasing, you see the function's decreasing here, and then it's decreasing. So it's actually decreasing everywhere. So we would say it's decreasing from negative infinity to 0, and it's also decreasing from 0, but not including 0 to positive infinity. Does not exist at x equals 0. So it's neither. If it doesn't exist, it can't be decreasing or increasing. But it's always decreasing. And symmetric, yes. It's symmetric around the origin. So if I draw a line, the way you can kind of tell symmetry, if you draw the line y equals x, so that's this one. So where's 3? There we go. So you can see that, you know, if I drew from the origin to a point here, say that there's a point that's on the other side of the origin, relatively speaking. And then you got the absolute value function. You can see that the domain is just like polynomials, it's all real numbers. The range is going to be greater than or equal to 0. Again, not equal to infinity. So that's range. It's even, because again, if I go so much in the x direction, either side of the origin, I get the same y value. X and y intercepts are the origin. From negative infinity to 0, it's decreasing. From 0 to positive infinity, it's increasing. And at x equals 0, it's neither. Because right here, it's like I'm being on a pinhead. So it's negative slope to this point, it's positive slope. You can't go, it goes immediately from positive to negative slope or negative to positive slope. So there really is no that, and it's symmetric about the y-axis or the line x equals 0. That's the same thing. And the greatest integer, what that does is it takes the x value and it rounds down basically. So if you have 1.3, this greatest integer factor just makes it x equals 1. So you can see here 1.3 is equal to 1. X equals 1.9. It's y equals 1. Here's y equals 1. So you just take the integer part of the non-integer. So when I get to 2, when x equals 2.1, you just show the 2 part. So that's there. So it gets to 222 and then jumps up. Okay, so that's it for section 5. I'm not even sure if I have any homework that I associate with that.